Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the topic of GIS data and spatial analysis. What is meant by spatial analysis or what is the process behind it? So spatial analysis is the mediator part which is based on the spatial data or the attribute data, or we can say that the input which is collected by the coordinates topology and its characteristics, so that it may be from by the use of GPS, or it may be by from the GIS, which is the descriptive part. So spatial data which is collected where, attribute data which is collected what. Means spatial data and attribute data are the inputs for the spatial analysis, where the actual process of examining the locations, examining the data, examining the various layers, attributes enclosed in that layer, relationship in between that attribute data and the spatial data, their patterns are studied and analyzed. After that analysis, we get the decision support with reference to the graphical representation, with reference to the document purpose, with reference to the tables, with reference to the bullet points answer just as a decision support, which gives the models that answer questions about connectivity, proximity, and overlay, buffering, etc. So the brain of the geographic information system is the spatial analysis. GIS spatial analysis is the process of examining geographic data to identify patterns, relationship, and various trends related to that. The spatial analysis is also the process of manipulating or enhancing the spatial information to extract new insights of patterns that were not immediately visible to the raw data. So civil engineering, it is used for site selection, route planning, environmental impact studies, and many more applications of that spatial data analysis. The technique allows us to answer the critical question such as where is the best site for a new reservoir, or which building will be impacted by this highway expansion. So with reference to that questions, we get the answers of that question by the spatial analysis. Let's move for simple data management to advanced engineering problem solving techniques. Now, with reference to the spatial data, overlay analysis is integrated spatial layers. So we have to consider n number of layers integratedly. The definition of that overlay analysis is based on the layers which are concentrated or considered for our analysis purpose, just like soil type, vegetation, composite map, and many more. So the stacking of two or more thematic map layers to create a new composite layer is called as an overlay. What is the objective behind that overlay analysis is to spatially interrelate. We have to spatially interrelate or correlate multiple types of information at the same location or at the same position. Just like example, where is the soil is unstable and the slope steep. So topographical point of view, the characteristics of topography slope we can check, and its type also. With reference to soil type or geotechnical point of view, we can check the stability and instability of the soil also. So overlay analysis combines multiple GIS layers to produce new information. So overlay analysis provides the information based on the process of stacking different thematic layers on top of each surface to create new composite layers or n number of layers. The objective is to analyze relationship between different data sets, which works by superimposing or correlating the layers such as land use, soil, slope, characteristics, and many more. Common methods for that overlay analysis includes union of layers, intersection of two layers, or weighted overlay analysis. With reference to that overlay analysis, it is used for site suitability, urban planning and resource management, where we can check the type of soil, characteristics of soil, property boundary and updated boundary or existing boundary with reference to the previous map, n number of land parcels and its deadlines, or we can say that the boundary lines, so that overlay is most important for site suitability analysis. Types of overlay, where two types based on that Boolean logic: intersection and union. So nothing but intersection and union are the two most common polygon overlays. Intersection, which shows the and means the retains only features common to both layers. So first circle is the A circle and second circle will be the B circle. So the combined part of A and B will be intersection part, used for finding sites that meet all criteria from A circle to B circle or A characteristics to B characteristics likewise. This concept is central to polygon on polygon overlay, where only the intersecting polygons are kept or considered for checking the attributes, combining the attributes or decision making procedure. Second part, with reference to that union, or we can say that OR gate, union retains all features from both layers, so that we can consider all the information which is incorporated in between two layers or combined in between two layers, using that combined data sets to create a comprehensive composite layer similar to the combining all polygons and attributes in a polygon on polygon operation. So for transportation engineer, for example, for transportation engineering point of view, intersecting a proposed highway polygon with reference to the land ownership polygon allows us to intermediate identification of all properties that must be acquired for the project. So as a civil engineer, we can use that overlay Boolean logic as an analysis purpose, so that we get the exact information in descriptive manner. Then we will check the attribute query, which is collected the information based on the attribute data, which is the descriptive data. When we can collect the data, we have to ask the question of what, means what type of data is this. So definition is related to the selecting features based on the non-spatial characteristics in the attribute table. Here here with reference to the ID 003, type is hotel, room is 150, pH level is 7. What is meant by pH level here? The water coming in that room of hotel which have the pH level 7. So from sites where rooms are greater than 100, then we can check that pH level. So mechanism behind that, use set of algebra where greater than, less than, equal to, just like operations we can plan or we can add, just like the query and the Boolean operators, so that with reference to that operators there may be a comparison, there may be a consideration, or there may be a overlaying concept based on that attribute queries we can generate and we get the answer. So owing towards that query analysis, which is the part of GIS also, basically, where GIS is used to retrieve the specific information from the collected data sets. The objective behind that is to filter and extract required data efficiently, which works through attribute queries based on the data values and spatial queries based on the location. So two queries: attribute queries based on data values and spatial queries based on the location point of view. So the queries use conditions like greater than, within, near, less than, equal to. So in civil engineering point of view, it is used for selecting suitable sites, analyzing land records, managing infrastructural data. Secondly, spatial query, where we have to ask. So we have to ask the question where it is located, so that it gives the positioning. So selecting features based on their location, or relationship to the other features. So here we generate the relationship in between the existing position to the nearby position. So for that purpose, topological rules are most important. They shows the neighborhood, that is containment, adjacency, proximity. Containment shows that inside this district, so that we can check which district it belongs, that position. Adjacency, touching the highway, which highway is nearby from that position. And proximity, where within 500 of the river. So likewise we can check the environmental conditions, hydrological conditions, hydrological parameters, or transportation parameters. So querying is the most basic powerful function of a GIS, which allows you to select features based on specific criteria. There are two types: attribute queries and spatial queries. So attribute queries, for example, select all pipes made of cast iron. And spatial queries, select all parcels within 500 meters of the river. In GIS, we use structured query language SQL to perform this task, where municipal engineers use that querying is the primary tool for asset management, where they instantly identify which parts of an infrastructure network require maintenance, monitoring based on age or material properties. Next part is the network analysis. Network analysis is the most important point nowadays for any city type area or any urbanization or urban planning and mapping concept, where each and every city must have the grid of roads, must have the grid of water grids for sewage treatment plant, for water distribution network. So we have to monitor the flow on the road or inside the conduits or pipes. So for that purpose, we have to check the origin and destination, where we can say that start node, which is the origin node, and end node, which is the destination node. So with reference to the traffic point of view, we have to analyze the path, which is the shortest one, and it may require less time, less traffic density. So the concept behind that network analysis is that analysis of linear features that are topologically connected. Analysis of linear features that are topologically connected, just like edges and nodes. So what are the operations? Just we have to check or cross check or consider or select shortest path, finding efficient routes based on distance or time. Secondly, allocation, where determining the service areas, just like fire station coverage, hospitals, schools, or railway stations, etc. So network analysis provides the persons who are living in that premises the connectivity, applications, or the availability of the shortest path. For municipal corporation point of view, that network analysis is used for the monitoring and controlling purpose, so that they also plan the maintenance activity accordingly. Which type of road or which type of conduit or pipeline may get damage or have the leakages, so we have to close which line wall, so that we can make the water supply also and the maintenance activity. We will discuss the buffer analysis, which is related to the zone of influence. So if we are planning to target or coordinate any location by using the GPS, just like example of the well, then with reference to that well, we can take some radius and we can mark a circle which shows that the buffer zone with reference to that GPS location, just like well. So basically, with reference to the geospatial information or some techniques, we can map or we can survey the area with reference to the zone of influence. A polygon or any circular shape which is created at a specified distance around a point, a line, or a area feature, that is the zone of influence, or we can say that the buffer area. With reference to that buffer area, which is based on with reference of that features, and we are comparing n number of features and n number of buffer at a time, then we can say that buffer analysis. So basically, buffering is a spatial analysis technique that creates zones around geographic features, where buffering is a proximity analysis tool that creates a zone of a specified distance around a point, line, polygon. To define a proximity zone, it works by generating circular or polygon or any regions or any shape regions around the lines, points, etc. The characteristics of buffer analysis includes that it is based on the distance and it is based on the elevations of the features. So buffers can be single or multiple with reference to its rings or with reference to its radius. So in civil engineering point of view, it is used for environmental protection zones, road safety, planning and utility management. So key functions are exclusive and inclusive. For example, exclusively safety zone around a factory and inclusive service area of a hospital. Based on that buffer distance or based on that zone which is selected with reference to some point, line or feature, their buffer distance is divided into two types: constant buffer distance and variable buffer distance. If we take a equispace or fixed distance for marking the circle, just like radius which is shown in picture 1, that called as a fixed distance or a constant buffer distance. In second, there will be a variable distance with reference to the obstacle in between them or obstacle near to that location. The barrier or any friction surface which is shown with reference to the image 2, then we can mark the distance functionally, and that distance may use for the real world applications. That second image, it is most important for the hilly regions or for the applications of road constructions and railway alignments, but in urban mapping and planning we prefer the constant buffer distance phenomenon. So constant buffer applies the same distance to every feature in a layer, such as uniform noise buffer around a highway. In variable buffer, it uses a specific attribute to define the distance. With reference to that, a river might have a larger buffer in a flood prone area and smaller one in a rocky terrain, just like the river phenomenon. With reference to that engineering point of view, we are using the variable buffer to model complex phenomenon like zone of influences for a pumping well in agricultural domain where the radius depends on the soil permeability. The flexibility allows us to create more realistic engineering models of an environment. Towards the real world applications of buffer analysis, where the road planning and the environmental clearance are the two examples taken for the study or the comparison. So image 1 itself explains that there will be a road alignment in white color. Apart to that road alignment, the roadway of black color line is there. So with reference to that, we are checking the impacted houses by the buffer of the roadway noise impact zone 100-meter buffer taken, and the houses which are coming in 100-meter from that alignment are taken for the road planning of impact of noise created by that highway or the vehicles who are traveling through that highway. Buffer used to determine the noise impact zones. So spatial analysis is what makes GIS a true engineering tool rather than just a drafting program. With reference to environmental clearance point of view or sitting point of view, we can check the blue dots. These blue dots are the cities, and with reference to that city capital, or we can say that the center, we mark the buffer area with reference to some radius. So with reference to that, most of the circles are separate, but very few circles are interconnected to each other. So means we can compare it with reference to any other two or in between two, just like intersection or and. Overlay used to find valid factory sites greater than 10 km from the cities, just like the industrial corridor or the distance which are required for the development of industrial zone nearby to the city. So by using querying concept, buffering and analysis overlays, you can move from simple observation to predictive modeling. Whether we are engineers who works for the optimization of resources, just like new railway, new highway, or for assessing the flood risk for a coastal development, these special operations provide us the quantitative evidence needed to support our design. Remember that the quality of our analysis depends on both the accuracy of input data and the logical steps taken for the consideration. With reference to that real world applications, we conclude the buffer analysis, which is most important part for the civil engineering perspective. Stay tuned guys. Happy learning.